Good afternoon, sir. I think sorry for inconvenience. Good afternoon, sir.
Yeah, good afternoon.
So, shall we proceed because the participants are about to join, they are joining. So, yeah, please start. Sir. Because
Okay.
there is no need of to introduce you because everyone is knowing now.
Okay, so now I'm going to start. The topic which is given to me is IPMA, IPMA. Okay. So I am showing my screen. So the topic which is given to me is IPMA. So there are two things here, I and P. So here I stands for important and P stand for performance. Performance. And MA comes here, map, map, analysis. So analysis. So this is the breakup of IPMA. So I stand for important map analysis and P stand for performance map analysis. So this is the just full form. Now we have to understand each in detail. So first of all, let's consider the performance analysis first. Performance analysis. And it is called performance map analysis. Now suppose you are having three construct, X construct, Y construct and Z construct. X is measured with the help of X1, X2, X3. Y is measured with the help of Y1, Y2, Y3. And Z is measured of Z1, Z2 and Z3. And suppose we are using 5-point scale to measure these items. And here 1 means strongly disagree, and 5 means strongly agree. Now the question is that this is basically the neutral. Now if your response is coming toward this side, so we can say that the customer is agree, and if we move to this side, the customer is said to be disagree. Right? Okay. So whatever be the case, whether it is disagree or it is agree, so we can at least understood that what is the agreement and disagreement of X and Y and Z. Suppose I calculate X mean, Y mean and Z mean. So this is the mean of all the values X, Y and Z. And suppose the Y mean is 3.7, Z mean is 3.2 and X is 2.5. So now how to represent these three means? So in this case, we can say that y mean is greater than z mean and z mean is greater than x mean. Or in other words, the respondent have more agreement with y, less agreement with s, and totally disagreement with x bar. So here we can say, let's say, I am saying that y mean is 3.7, z mean is 3.3. This is just an hypothetical values, and it is 2.4. So what conclusion we can draw from here? It means the respondents have highest agreement with y, not highest. We can say moderate agreement with z, and respondent have disagreement with x. So at least here we can know, we can say that where the respondent have the highest agreement, where they have the disagreement, where have the moderate agreement. So we can analyze this thing from their mean. And if we represent it in the graph, because we are representing all the mean through the graph, so the graph is coming like this. This is x 2.4, this is y and 3.7, and this is z 3.3. Right? So now if you see this graph, this is called agreement, and this is the variables or you can say factors. So you can say the respondent have the maximum agreement with y, and followed by z, and followed by x. So this graph is known as performance analysis, performance map analysis. Okay, now in this case there is one problem, that benchmark is 5. So in this graph the problem is that the benchmark is 5. So we have to find out some better benchmark to represent this graph. So now what we are doing, so now the reference of 5 will be shifted to 100. Actually, why this is so? Because in if you compare something with 100, you can have better picture, right? What is the agreement? So if agreement is more than 75, then we can say the strong agreement. Then if the score is between 50 to 75, then we can say moderate agreement. And if it is less than 50, so we are moving towards disagreement, right? So now this is the modified version of performance analysis, where we are comparing with the 100. Okay, now the problem is that how to compare with the 100, how to shift the value to the 100. So we apply a formula. Suppose you are having the x variable, and x construct is measured with the help of x1, x2, x3, and we are having the respondent. Suppose we are having 5 respondent, so they are giving the responses like 2, 3, 4, 1, and 5. There are 5 respondents, they are giving these responses against x1. Against x2, they are giving you 3, 1, 4, 5, 1. Then in x3 you are having 2, 5, 3, 2, let's say 1. Now how to convert it? So then we apply a formula. So find out the minimum value, find out the maximum value, and here you know that the minimum value is 1 and maximum value is 5. So what is the performance value? The performance value is x minus 1 upon 5 minus 1, or simply we can represent it by the xi minus minimum value divided by maximum minus minimum value. So if you apply this formula, you can convert any value into the performance value. So we can calculate the performance value of x1, performance value of x2, and performance value of x3. Now the performance value of x equal to performance value of x1 plus performance value of x2 plus performance value of x3 divided by 3. So this is the performance value of x3. So I'm giving you one example. Let's say we are working with or this data set. Let me open a data set. Let's start with this. Okay, so let me explain this data with you. The FI stands for financial incentive. So this is my construct number 1. Career growth is my second variable. Career growth. And then we are having the work climate in the organization. Work climate. Let's give some color. Interpersonal relationship is another thing. This is, let's say, it is color this. And now all these 4 factors have an impact on perceived work quality. So perceived work quality is my dependent variable. Okay, so we can have some better color. Yeah, like this. Okay, now perceived work quality is my dependent variable, and all these are my independent variable. So I want to do performance analysis on this data set. So how to do it? So first of all, I will save all the values here. Again, I am copying this and paste here. Now I am applying the same formula for each value. This is equal to, so what is the corresponding value of F1? The corresponding value of F1 is 1. Okay. Minus minimum value is also 1. And divided by, because maximum minus minimum value is always 4. So on this answer will be always 4. Okay. So one thing I want to check whether I am applying the right formula or not. X minus minimum, maximum minus minimum. Yeah, I am applying this right formula. So now I just drag and drop this. I am applying the values with all, and similarly I will drag it to calculate the for all values. So we can do it for all. So we have to do it for all. And let me check whether I can do it for all together. Yeah. So now I converted into the performance value. So after that, I will calculate the performance value for each variable. So I'm just taking 2 decimal and in center. So I calculated the performance value of each number. After that, I will calculate the performance value for each variable. So what I'm calculating, the performance value of the item wise performance value. So you just do one thing, nothing. Take the average of all these values. So this is 65. And similarly, we can drag and drop to all. So this is the performance value of each item. Now I have to calculate the performance value of each factor. Performance value for the factor. Okay. So factor, I have to recall what is the factor. So I can fix this cell. So I'm freezing plane, freezing top row, so that I can see where is the factor. Okay. Now you can see that this is the F1. So I just margin center and I'm applying the average of all these values is the performance value of the factor financial incentive. So I write here financial incentive, the performance value is, okay, let me write here. So the performance value of financial incentive is 66%. So we can write it is 66%, or percentage we can drop because it is in number. Yeah. So the performance value of financial incentive is 66. Similarly, we have to calculate the performance value of each number. Okay, so merge and center. The performance value is the average of all these numbers. Some problem. Average of AL 360 to AR of 361. Okay, 360. So it should be 360 also. Now answer is 62. So I can write here the performance value of carrier growth is equal to 62%, or we can write just in 62. Let me take these values here so that we can type. Okay. Now we are calculating the performance value of third. The third is working climate. The performance value is average of all these numbers. It is answer is 64. So work climate is 64. Similarly, I have to move further, and this is interpersonal relationship. The performance value is average, and all these values. It is 63. So I am writing here interpersonal relationship is equal to 63, and we are having the last value, perceived work quality. So we have to calculate the average of all pink values, 67. So the perceived work quality, the performance value is 67. Now I have calculated the performance value of each. So let's cut it from here and take it to the take it here so that we can plot the graph of this whole diagram. So now I have calculated the performance value of each factor so that I can plot it. So the first map I'm making here is using these values. Insert the recommended chart. We are going to make this chart. Okay. Now we have to make it chart the professionally. So here, okay, let me make the chart first. So go to plus, remove the grid lines, click on any bar, format data series, and we can write here very clear by point. So I think this is much better. And we want the values here. So these mean values also I need. Okay. Now I think this is much better. So I can write here the performance map analysis. Performance map analysis. So this is my first part of the analysis for the session. So you can do the performance analysis like this. And now what is the conclusion of this map? So we have to write this. So I'm writing here. Number one, the highest agreement with PWQ, but because PWQ is the dependent variable, so let's start with this. Then the employees have maximum agreement with financial incentive. Followed by work climate, followed by the interpersonal relationship, and the last is the career growth. Okay, now let's wrap the text. So you can see that our analysis say that the employees have highest agreement with perceived work quality 67, and they say that this is due to the financial incentive, followed by work climate, followed by interpersonal relationship, and the last agreement, the least agreement, but they are agree with this also. So the last agreement we can see with the help of career growth. So all the four factors are more than 50. So we can say the employees have the agreement with almost every factor. All the four factors they have contributed to the perceived work quality. But the most contributing factor is the financial incentive, because most of the respondents have the agreement with this, followed by work climate, the followed by interpersonal relationship, and in the last, career growth. So now we have achieved our task, and I hope we can understand what is the measure of perceived work quality is also there. So now we can say we have achieved the concept of performance map analysis. So this is my first part, performance map analysis. Now we are moving to the second part. So if you have any query up to this, you can ask. Okay. So no question till now. Now I'm moving to the second part, the importance analysis. So let me open the PLS software. So I'm opening the PLS. Yeah. And I'm running this exercise number 1, I think. Yeah. So perceived work quality, this is my model. Now I'm calculating the bootstrap and I'm doing the complete bootstrapping. Start calculation. So the software is giving me result. And I have to see the total effect. So we have the total effect here. Only total effect is required. So I copy the total effect and take it into the Excel format. Uh, this is the total effect. Now I need only this value, not any other value. Okay, to some extent, T statistic is important and P values are not important. So the beta is found to be maximum. Let me take the values away near to our value. Yeah. So we have the values here. For career growth, the total effect is found to be the effect of total growth on the perceived work quality is found to be 0.262. So career growth is found to be 0.262. This is nothing but the beta, or we can say the impact. And this is the performance. This impact is actually known as importance. So we can say the impact of career growth on the perceived work quality is 0.262 and financial incentive is 0.171, 0.171, and then interpersonal relationship, work climate is 0.178, 0.178, and the personal relationship is interpersonal relationship is 0.237, 0.237. So we have done the task, and because it is a dependent variable don't have any independent variables. So we have these kind of results. Now I copy this result once again. Let me paste here, and I'm taking only the performance, only the importance, not the performance. Okay, now you can see that I take only the importance values of the constructs and I'm plotting it. So I'm taking this value. Now this is just making the graph. Format data series, fill, and very clear by point. Okay, now it is done. Grid we have to remove. So this graph is known as importance analysis. Importance map analysis. So now we can tell the career growth is having the highest effect on the dependent variable, followed by interpersonal relationship, then work climate and the financial incentive. So here we are having some confusion. Let me show you in the Word file. I am taking these two graphs in the Word file, and let's take the layout of the landscape. And I'm taking the two graphs here. Okay, can we take in one page? Yeah, we can take like this. So both the graphs I'm taking here. This is the importance analysis copy, and I am pasting here. I hope you can see it clearly. The second graph is so where is the second graph? Excel में है, हाँ. So we have the second graph, this one. Copy and take this. Okay. So we have two graphs from here. One is called performance map analysis, and second is known as important map analysis. Now give me the question of my answer. Answer of my question, sorry. You have to give the answer of my question. In both the cases, we are studying the impact of the different factors on the perceived work quality. So, if for which work quality the employees have the maximum agreement, answer is financial incentive. Which variable is having the maximum impact on perceived work quality? The answer is career growth. So why the different responses? Why the same responses gives you different results? So I am asking in graph number 1. I am asking. So which graph is this? Performance map analysis. Let me take in only one graph. Yeah. So now you can see both the graphs. So in performance map analysis, my question is which variable, to which variable the employees have the maximum agreement with the with the factor. So your answer is financial incentive. So they have maximum agreement that if the company give us financial incentive, the perceived work quality is improved. But in importance analysis, which is based on the beta, whenever I am saying that which variable is the most important variable in influencing the perceived quality, answer is career growth. So these are the two approaches of identifying the most important variables in the analysis, and the performance analysis is on the basis of the average, and importance map analysis is calculated on the basis of beta. Okay, so first of all, try to understand these two things, and then we will move to combine them. Because up to this point, I calculated the individual value of performance and individual value of importance. Now, how to club them together? So that is the point. So give me a minute. I'm coming just. Okay. So we have done the performance map analysis. We have done the importance map analysis. The performance map analysis is telling you that for which variable the respondent have the maximum agreement, and the importance map analysis is informing you that which variable is having the maximum impact on the dependent variable. So answer is in front of you. And now the question is that how to combine the two in one map. So that I'm doing now. So what I'm doing, I'm combining the performance and importance. So let me try. So I am taking this value. This is performance value. This is importance value. And because importance value and performance value are very small, so let's see, can we do it here or not? Uh, so I'm going to make this scatter plot. Okay. In scatter plot, I have two different values. No. Yeah, we require actually this chart. Yeah, this is scatter chart and okay. So now I have this chart and the problem is that now we have to identify and make the table. So you can see that the x-axis is coming to the importance and y-axis is coming to the performance. Let me check. Is it the value? No, no, no. उल्टा हो गया देखिए ये performance coming in the x-axis or that comes in the y-axis. So this is opposite. I need, so I am deleting it. Actually, I need importance in the x-axis, cut, and need performance in the y-axis. So I need importance on the x-axis and these in the y-axis. So let me take these values in another file so that we can see it clearly. Let's try to make the graph again. Insert recommended chart. This chart I need. Yeah, so I have the chart. Now I have to make some changes here. The axis titles. Yeah, so this is called performance analysis. Performance analysis, and this is called importance analysis. So let's write here importance analysis. So grid I don't require. Now what else I need? Trend line, no trend line, grid line, error bars. Okay. Data labels, no. I need actually the labels, but not data labels, the value, the labels of. Okay, let me, actually there is a method to, I don't know how to add these values, okay, into this, but so I can add manually, no problem. You just go to the text search, text box, and so I am adding the 4 text box here. All right. Yeah. So which value is this? This is the 0.17166, 0.17166 financial incentive. Financial incentive. So this is my financial incentive. So I take the financial incentive here. Similarly, for this, I need, this is the 17864 work climate. So again, I am adding a text box here. This is the work climate. Work climate. Okay. Similarly, okay, actually dotted line, these dotted lines are much better. Copy and paste. So we paste 2 times because this is much better. And one more time. So here I am deleting it. This is the work climate. Okay. Now this value is this value is 23763 23763 23763 यानी interpersonal. So interpersonal relationship. So I got the value for interpersonal relationship also. And finally, I am going, this is the last value. So where is career growth? 262.62. Okay, I think this is 262.62 career growth. So now I have calculated for all. Okay. So this is my this is known as IPMA and IPMA. So now we can paste here. So this graph is the final result for IPMA analysis. So IPMA analysis is telling you that the customers have the maximum agreement with the financial incentive. The respondent have the second highest agreement with the work climate, the third agreement with the interpersonal relationship, and the last agreement means performance. So last agreement with the career growth. However, if you see the impact is x-axis. The impact of career growth is found to be the highest. Impact of interpersonal relationship found to be second highest. Work climate third highest, and financial incentive is the fourth highest. So this exercise is known as IPMA analysis. So all these exercises I am doing manually. Now I am showing you how software is doing it. Okay, so this is our data set. First of all, you have to make this graph. This graph, calculate. Go to IPMA. You can see that importance performance map analysis, and target variable is perceived work quality. Just run it. And now I'm showing you all the values which we calculated. Go to performance. Performance values are calculated here. So you can see that the performance values are exactly same as we calculated. I'm showing you. This is the software values. So for career growth, the value is 62. For career growth, it is 62. You can see. For financial incentive, it is 65. My value is 66. Yeah. So actually, my values are round off values. If I increase the, okay, so these are the round off values. And interpersonal relationship is 63. Interpersonal relationship is 63. Perceived work quality 67. It is 67. So my values are almost equal to these values because I'm taking without decimal. They are taking with decimal. The only difference, right? So this is called latent variable performance. Latent variable performance. So I hope you understand now what is the meaning of performance here. So this is the performance values, and if you see the total effect, all these values are all these values are basically the beta, the importance. Because all these values I take from this software, no need to compare. Career growth 262. So carrier growth 262, you can see that. And after that, you just see the meaning of, you just see this graph. You just see this graph. This graph is known as importance performance map. Importance performance map. So this red value is the carrier growth. You can see the carrier growth. The blue value is financial incentive. Financial incentive. Actually, this graph quality is not good if you compare the quality with my graph. So this graph quality is 100 times better than the quality provided by the software. So therefore, whenever I need to do the IPMA analysis, I don't use this graph. I make my own graph, this graph for IPMA analysis. So this analysis is known as importance, performance, and map analysis. And in the research paper, I'm showing you one thing. So because one of my research paper is going on, blockchain green paper. So in this paper also we reported the IPMA graph, but we take the IPMA graph from the software. So where is the IPMA graph? Yeah. So this is the graph we reported in the research paper, and you have two choices: either to report this graph or to report this graph. So you can see both the graph qualities, and I prefer to make this graph. And this graph is telling you where the respondents have more agreement and which variable is having the maximum impact on the dependent variable. So in 1 hour, I completed the each and everything of IPMA in using the manual calculation and using the software calculation. So that's it about IPMA from my side. If you want to discuss any other topic, most welcome.
Participants.
Because if, the I think the main topic of IPMA is clear, and because we have time, we can discuss some more topic if you need. Uh,
Participant, please respond.
Sir, although this question is not related to IPMA,
yeah.
but I had a query regarding parallel mediation. So
Mhm.
we previously had a session on parallel mediation where I had a query that suppose if I am taking two mediators which are opposite in direction,
Mhm.
say one of them is negative and one of them is positive. So
Mhm.
how do I interpret the results in that case? Because the total indirect effect gets reduced or either differs.
Actually, in parallel mediation, we have to see the separate values of mediation. Separate values for mediator 1 and separate value for mediator 2. And whenever we talk about the total effect. So the total effect in parallel mediation is same, and it is going to through two different paths. So path number 1 and path number 2. So which software you use for analyzing that?
Sir, I have used Amos and N plus.
No, no. Actually, the parallel mediation is best examined with the process. So process give you the best result for parallel mediation.
Sir, with process, there is a limitation of 10 mediators only. So mostly like I'm using 14 to 15 coping strategies as mediators.
Yeah, but
That's all.
actually, 14 mediators, 14 parallel mediators.
Yes, sir, it's a health psychology related research. So stress, well-being, and we have 14 coping strategies to deal with it. So
So are you sure that in process there is a limitation of
yes, sir,
10
I tried process in as well as there were two more versions of
process?
this. Yes, sir. It didn't work. It doesn't take more than 10. And second thing which I encounter is that when we use indicators, the results differ from when we use the aggregate total for calculation of mediation.
So then in that case, you should try PLS also. Because I think PLS can handle the 14 mediators.
It does, but the interpretation of result is the tricky part because a lot of them are negative, a lot of them are positive. So how to interpret? Should we consider total? If we don't consider the total effect, then the result sometimes it becomes very not comprehensible enough.
Hmm. Okay. So if we can do one thing, if we can take the reverse code of the negative statements, then I think your problem will be solved.
If we take the negative code, eventually,
No. I'm saying that the mediators which are giving you the negative impact, if you take the reverse code of these mediators.
so I'll just discuss with you examples of the mediators I have. So suppose one of them is substance abuse, the other one is positive reframing. Now reverse scoring them would actually theoretically make not much of sense to it.
Statistically, it is fulfilling your condition, but I understand that the conceptually, because one is negative and one is positive. So if you take the total effect will cancel each other.
Yes.
The problem is this. So I understand your problem statistically, but statistically the problem can be solved if you take reverse coding, and you can explain it with the conceptually theoretically, but the actual value is calculated only by taking the reverse coding.
Okay. So in that way, it would become a positive direction, and both of them would add up and give me a total.
Yeah.
So one more query I had, or which I had on the first day also.
Mhm.
Normally, when we use methods like maximum likelihood is the most appropriate used method in CFA. But if we use some method like unmated least square or GLS because of Haywood cases, then the modification criteria or cutoffs they get changed. So how do we deal in such situation where you do not have chi-square, you hardly have an RMR, NFI, or Seaman? So what should we do in such a case?
Basically, the Hayward problem is the problem which is coming due to the very high correlation and some abnormal values in the data set. So that itself a problem, right? So when you already have the Hayward problem and you are to avoid that, you are using unweighted least square or GLS or some other methods, you already get the wrong values. Maximum likelihood estimation is considered to be the best among all these available values. The problem is not here for the maximum likelihood estimation or for any other value. The problem lies in the data set. So if you remove the problem by changing the method, you will not get the good results.
Right.
So actually, whenever we analyze the data, we have to check what are the different problems that data is having, because I tomorrow morning I have a slide, but actually I did not show that slide. So let me just showing that slide to you. So normally when I consider these topics, so I also discuss that the problems. Like let me find out the. Okay. Actually, there are many problems like I'm showing you all these problems. So these are the problems which we found in the data set, like model non-convergence, non-positive covariance matrix, under identification, invalid values for path estimates, negative covariances. So these are some abnormal problems that we get we get when we are having the problem in the data set, right? So Haywood cases is another problem. And now the question is that when you are having these problems, and to solve these problems, you are changing the method, that is not the right method. That is not the right solution for solving the problem. So I never suggest you to change the method if you are changing the method because of these problems. So my suggestion is that first of all, find out the reason of these problems. Why Hayward problem is coming? Why non-convergence is coming? Why non-positive matrix is coming? And most of the time, I found that there is some problem in the data set. If you remove those problems, the maximum likelihood estimation is giving you the best solution.
Yes, sir. In fact, the problem in this which I'm discussing is that I have one domain which talks about family transition, and it has only two items, marital and parenting, which are highly correlated naturally.
Yes.
And the rating point is 5-point Likert scale, which sometimes it is considered
No,
as the
no.
lowest
Actually,
rating of
in SAM, you
any.
always have a problem because uh,
Yes.
actually, what problem I found in the 5-point scale, if most of the people are giving responses 345, 345, there is a lot of by chance correlation comes in the data set, and this forms in the huge biasness in the data set. So the unintentional correlation which comes in the data set, creating a huge biasness, Haywood problem, and all other problems. So sometimes scale is also a problem. I'm telling you. So I never suggest 5-point scale in the SAM model. So, and I know that whosoever writing a paper using the 5-point scale and using SAM, the SAM is based on the data manipulation. It is just impossible to get the good result in SAM without doing data manipulation.
Yes, sir. And the same thing I observed. So I was just thinking of alternative methods which could help me out. And one was changing the
Better you
estimation.
change the scale.
Okay. That
That is
exam
one
range would be.
possibility which helps you in removing all these problems.
Okay, sir. Thank you, sir.
Sir, I have a question.
Yeah.
Please ask.
Uh, yeah. Sir, suppose we are not using a well-established scale to do our research. Okay. For some study, if I'm not able to find a well-established scale, then to do the analysis, what do you suggest? For example, if I do EFA, exploratory factor analysis first, to explore the factors and name the constructs on a pilot data. Okay. Thereafter, once I complete the data collection and I do a confirmatory factor analysis to confirm the factors which I have identified during EFA. And finally, then I use, either multiple linear regression or I use a MOS to test any mediating effects, etc., etc. Is that the right approach to go ahead, sir, in that case?
Uh, in your case, I found two problems. Number one, EFA is not applicable on the pilot survey. Number two, EFA only examine the correlation between the items, and EFA is only applicable when the correlation between the items is meaningful. Now, the problem I'm telling you, in pilot survey, you have the data of around 50 or maximum 60, 70, right?
So
And
it was around 150, yeah.
in case of one, actually in EFA, the minimum requirement is 5 times number of items multiplied by 5 times. If this problem is satisfied, then EFA you can apply. And second case, EFA is only applicable when there is a natural correlation between the responses. What happens sometimes in different areas, the correlation between the items is natural. For example, in marketing, in shopping behavior, the correlation between any item is obvious, right? But EFA is more applicable in the areas like social science, psychology. In psychology, EFA is meaningful, but in some areas it is not meaningful because every item is correlated with every other item. So especially in SAM, we allow the correlation between the different items, right? This is a very natural thing. So in those cases, CFA is much better. EFA may give you some problematic results. And therefore, I found that researcher drops a lot of items because of this EFA without understanding the problem of EFA. So EFA actually is a very, very sensitive technique. We should apply EFA very cautiously. So that is the problem. And apart from the EFA, when you develop a scale, there are many other methods for developing a scale. EFA is only one of the methods for use for developing the scale. You have many other methods. So you can also go for other methods if your purpose is to develop a development of a scale. But I believe that CFA is much better than EFA.
Okay, sir.
Sir, and is it necessary that EFA and CFA should be done with the same method? Normally, we use principal factor analysis or component analysis for EFA, and for CFA, we are using maximum likelihood. Does that make much difference?
Normally, EFA we apply principal component analysis, and CFA we go with maximum likelihood estimation. But the rule is that you should not apply EFA and CFA on the same data set. You divide the data set into 50-50%. 50% for 50% is applicable, used for EFA, and 50% is used for CFA. If you are getting the same result, then you can say your data is valid, your model is valid.
Sir, so what you said is in CFA we need to divide the data into two parts and then
No.
perform. Sorry.
Not in CFA. You
Okay.
divide the data into two equal parts,
Okay.
randomly.
Okay. Okay.
On one part apply EFA, on
Okay.
second part apply CFA,
Okay. Okay.
and check whether you are getting the consistent results in both. If yes, then your model is valid. Okay, any other query? Sir, if you allow me, I want to show some of the latest methods with using any other software.
It's our pleasure, sir. Please.
Yeah. Because of the time, because of the time availability, I'm just showing it. Actually, now the new technique is coming. The technique is known as image embedding. Okay, now what is this technique? I'm telling you. So let me give one example. There are many examples. If you put a photograph in the Facebook will tell you that the person who is standing near to you, is Ramesh, Suresh, or like that, right? So when Facebook can recognize anybody in the picture, it means this is something good, right? So most of you have feel it. So whenever you put any picture in the Facebook will tell you that this is Ramesh, Suresh, Sita, Geeta, whatever be. Similarly, when you go to the airport, the camera recognize your face, and the camera inform the police officials that he or she is, your whole background will come. And I'm telling you one more thing. In India, if you go to any person's house, or you can see some locks. In India, we apply the link tale, or ye jo local tale hote hain, local doors, right? So we apply all these doors. But if you go to a foreign country, they are not using it. They are using face locks or digital locks, or So these locks you can open only if you use your fingers or the eye or eyeballs or the face recognition. Similarly, you can open and close your laptops and mobile phone with the face with the images. So now we are moving to such a area that even we can analyze the images. So I'm just showing you one exercise how images can be analyzed, right? So this is the purpose of remaining session, and I assume you will like it. So give me a minute so that I can open the software. Uh, I'm using the Orange software for the demonstration. This is the software, Orange software, and I'm using it. Okay, so this is a software, and I'm going to predict something. Let me show you some of the exercise. So maybe you may heard about this software first time. So I have my all the pictures in this folder. So you can see that these are the different pictures. So there are 145 pictures in this folder, and I'm going to analyze this. This is the folder name. Okay. Now in this case, we are having a option called image analytics. You can see this option, image analysis. So you can see this option called image analysis. So I click on the images, import images, and I'm going to import the images. All the images are here. So I put all the images in this folder. So you can see that the software is saying that you have 145 images in this folder. And now we can image viewer, and if I click on this, I can see all the images. I can see all the images here, and if you convert into a data table, the images can be converted into data. So this is the raw data, and you can go for the image grid. Let me check it is working. No, it is not working. It will work after the analysis. And I am going to the image embedding. So this is a technique. So this is a technique which is very, very useful in nowadays. So now you can see if I click on the image embedding, so all the images are converted into the data. So let me show you the data table. If I show you this is our original data set. Now all the images are converted into, let's say, 1,000 variables. All the images are converted into 1,000 variables in 1 second only. You can see that how fast the software is. Software created 1,000 features, 1,000 feature variable into this. Now the question is that how can we use these 1,000 features, right? Now I'm telling you how to use it. So I'm applying the k-mean clustering. You can see that k-mean clustering is available here, and I'm asking the software. I want to group these pictures into 2 groups to 8 groups. Minimum I need 2 group, or minimum let's say 1 group, or let's say 4 group, or 2 कर देते हैं. So I want to group these images into 2 to 8. Software is telling me if you go to 5, it is much better. Now I have some methods like initialization with k-mean or random initialization. So these are the methods which software will telling me. And normalize columns, if you don't normalize if you normalize the columns, normalize means calculating the normal values as z scores. So software is saying me if you make 5 groups, it is much better. So let me take 5 groups. Okay. Now came in clustering is telling me that I can make the 5 groups. Okay, let me see the 5 groups. I make this scatter plot, and the software is showing me that these are the 4 groups. These are the 4 groups you can make. So all the images can be converted into these 4 groups. Yeah. Now I'm putting this picture here, and I'm going to the image grid. I'm going to image viewer, and I'm going to save images. Save images. Okay, so this is the program I follow in my modeling. So this is called machine learning algorithm, and let me show you. So this is the scatter plot. The scatter plot is opened here. I put the image grid. Image grid, I keep it here, and I click on the image viewer. Image viewer, I put it here. Okay. So now I suppose I want to see this group. So let's see this group. In this group, these are the pictures. The software put all these pictures in one group. So if you see, all these pictures are of one category. So most of them are group photographs. Yeah, most of them are group photographs. If I click on this group, let me show you this group. In this group, software take my all individual photographs in one group. So all the pictures comes in one group. So software is very, very smart, and software is taking all individual pictures in one group. Similarly, if I go to this, the third case, a software take all the advertisements. So all these are the advertisements, and all these advertisements comes in another group. So you can see that these are some of the advertisement I put for the promotion. So all advertisement comes in one group, and if I click on this, okay, now software take all the Zoom pictures in another group. You can see that all Zoom video sessions are distinguished, are separated by the software. Similarly, if I click on this, the last group, okay, let me take this. Okay. Now software is taking all these pictures. Now these pictures are the demonstrations. Okay, I think the video lectures on Google Meet comes separately. So these are the PPTs or Google Meet. Most of the videos in Google Meet are putting separately. Okay. Yeah. So you can see that how smartly the software is doing all these things. Now I can do one thing. Now I can save all these pictures. Let's say this is the group, and I put the image viewer so that I take this is the Google Meet pictures. I save Google Meet pictures, and I'm saving in this here. So I'm creating a new folder, and this is the categories of pictures. So now I'm taking a new folder, that Google Meet, and save. So all the pictures, these 22 pictures comes in the Google Meet. Now similarly, I click on this picture, this part. This is those Zoom pictures I save as. Now I'm creating another folder, Zoom, save. So 25 pictures comes in different folder. Now I go to this and I go to this. Okay, let me select this. Yeah. So all these are the advertisement. So I'm saving in next folder advertisement. And okay, now I go to the second group. Second group is my individual. So my Ajay, I am putting the next new folder, and all my individual pictures comes here, 13 pictures. My last folder is this. These are the outdoor pictures. So I can say outdoor or group pictures. Yeah. Now you can see that within 5 minutes, I categorize my pictures and I put all the pictures in different folders, right? So you can see that now I have a new folder, categories. So where is the category? So where is the folder? Okay, let me find out the folder. Yeah. So I divided my pictures in different categories. You can see that group, right? Yeah. Okay. So this is the one example. Now I'm giving you another example, right? Actually, how this example can be useful, I'm telling you. In medical science, so the benefit of this exercise, I just showed you the one of the machine learning programming on the pictures. So those who are in medical science, they put all the pictures in one folder, and the software will tell you that these pictures are of similar type. These patients are suffering from same problem. These patients are suffering from other problem. These patients are suffering from other problem. So in medical science, this is very, very useful. Now in other cases, those who are doing the botany and all, in botany, the images play a very important role. Then those who are in marketing. So the marketing, if you take the pictures of the advertisement, the software can categorize all the pictures into different categories. So you can do the content analysis or the other analysis on the different pictures. Similarly, I'm telling you one more example. If you take the pictures of different heroines or heroes, whatever be, or models, so you can take all the pictures of different models, and software will this software put Amitabh Bachchan in one category and Akshay Kumar in another category and Salman Khan in third folder. So software will identify that who is who. So this algorithm is playing a very important role in different areas. Actually, it's upon us that how we use it, right? So similarly, I'm showing you one more exercise using the orange on images, that how to predict the images. So how to misclassify the images, how to predict the images. So now I am showing you another exercise, and I hope you will like it. So I'm showing you the exercise number 2. So I'm just deleting it. The next exercise I'm opening, give me a minute. So first of all, I'm taking the images. So now I'm showing you, I have images. Okay, in this is a folder, pictures. I created the 5 pictures, 5 folders here, and I mix the 4 pictures. And I want software to tell me that where the misclassification is. So I take this. I'm taking the folder pictures. I'm taking the pictures, and there are 5 folders. You can see I'm selecting the main folder. Now software is telling me that in this folder there are 159 images with 5 categories. Okay. Now I want to predict the categorization of the images. So first of all, I go to the image viewer where I can see the different pictures. So these are the different pictures. And then I go for image embedding. This is the machine learning tool. And now I go to the data table. So you can see that 159 images are converted into 1000 variables. And so that we can apply the machine learning tools on it. So I'm going to test and scores. And I go for ROC analysis. I go for confusion matrix, right? I go for predictions, and then confusion matrix I'm going to image viewer. Okay, now let's make the models. So first model, so for model we can take the random forest, then we can take the SVM support vector machine, then we can take the neural network, then we can take the logistic regression, then we can model it by tree method. So I want to use tree method also, and I want to use the KNN method. I want to use the any other method I want to can use. Let me check. Python random for SVM, tree, logistic, neural network, KNN. Okay, almost I taking all the linear regression will not work here. Naive bias. So these are the prediction models. And these prediction models work on the data and give me the prediction. Okay, now I want to compare all the model first. So software is predicting, you can see 13%, 14%. So give the time to the software for the prediction. So software is running and running all the models on the photographs. Okay, now I go to this result and I am dividing the machine learning algorithm with 90%, 10% the testing and training ratio. So training ratio is 90%, testing ratio is 10%, and I am running so you can see the area under curve, or I think this classification accuracy is the result. So we compare that KNN is 81% accurate, tree is 85% accurate, SVM is 87% accurate, random forest is 84% accurate, neural network is 87% accurate, and naive bias is 85%, logistic regression is 84%. So I selected the neural network method or SVM method. I think SVM method we can adopt here. The highest accuracy I found in case of SVM as well as neural network, 87.4, 95, 95, 87.4. So I am happy with this. And now let me go to the ROC curve. The ROC curve is showing me that this orange line is giving me the most better prediction. This orange line, kaun si hai orange line? KNN, naive bias. Okay, SVM, I'm not able to relate this color with here. So I hope this is the neural network. No, not neural network. SVM. SVM is giving me the most or better prediction. Okay, so you can compare the different lines with it. So if the line is farthest from this dotted line, that model is considered to be the best. Then you can go for the predictions. Each model will predict, right? So these are the different predictions. And finally, I'm going to the confusion matrix. And I want to see, I want to predict, use SVM model. Okay. And I click on the image viewer also, so that I can see the images where my prediction is right. So in 36 cases, in these 36 cases, the predicted model said they should come in the ad. The actual is they should come in the ad. So both are saying that these pictures should come in the ad. So there is no confusion in these pictures. But if I click on this, the software is saying that it should also comes in the ad. But I mistakenly put this picture in my individual photographs. So you can see that how much software is accurate in suggesting me. So software is saying that this is not your individual picture, this is your advertisement. So put this picture in the ad. Similarly, others. Software is saying that all these pictures are added. Put these pictures into ad. This is misclassified pictures, right? So, and I think the software is true. Software is suggesting me the right thing. And similarly, I put this picture in the outdoor, but software is saying that no, this is not an outdoor picture. Similarly, I put this picture in the Zoom, but software is saying that this picture is an advertisement. Use this picture as an advertisement. So you can see how accurately the software is predicting or misclassifying the pictures. So this is the exercise. Similarly, we can do it for 21. In 21 cases, the software is saying that they are individual, and I put also in individual, and there is no confusion in this category. There is no confusion in this category. Similarly, in case of others actually, let's say Zoom. In Zoom, the software say these pictures should come in Zoom, and I also put come in Zoom, but the confusion in this is there. So I put all the picture in Zoom, but software is saying that no, I put these picture in others, but software said that you can take all these pictures in the Zoom. So the software accuracy or prediction is very high in images. Okay, so two exercise I just demonstrated in short. Okay, so this is just a demonstration of the image analytics that is a very growing area. So whether you are in marketing, whether you are in the medical science, or whether you are in architecture, whether you are in design, media, so you can learn all these things. And I would like to take 5 more minutes for my presentation. After that, we will have something new. So I am showing you one more thing. Data visualization is the new step, new skill set. Let me show you a simple data set. Reports PPT. Okay, I am showing you one more thing. So this is a software. This is a software. And actually nowadays we want to make the reports, different type of reports. This is a very advanced software for report writing. So like I'm showing you different charts, how you can make the reports. The most advancement in the charts, this is a map chart, and this is a word map. So how to create all these reports? So this, okay, word map. Okay, fun. So you have seen different type of charts here. Line charts.
Sir, please present your screen.
Okay, I have not presented this skin. Okay, sorry. I by mistake. I forget. So thank you for reminding.
It's okay, sir.
Yeah. So basically, I am showing you the power of a software. This software name is Power BI. Actually, this software is very good software, and you can improve your presentation skills and the different skills, presentation skills, visualization skills by using this software. So I'm showing you the 25 or 20 type of charts that we can create it here. So this is the pie chart, donut chart, map chart, and this is also the format of the map chart, funnel chart, and line chart. Line chart you have already seen. So, but line here can be created in different formats. Then slicer charts, ribbon charts, hierarchical charts. This is the combo chart and tree chart, scatter plot charts. So this is a animated scatter plot. So we can create some animation in the charts also. So this is animated. These two are the population of India and China, how they are moving in the last 50 years. So this is a animated chart. Then we are having a waterfall chart. These are the animated chart, how the sales of different cities are changing with time. So animated bar chart. This is also animated chart. You can see. So I think actually I put the speed very slow. Okay, now let's move to the another chart. So this is a drill down chart. So I don't know whether you have created this kind of chart earlier. So this is a drill down chart, and similarly, this is a word cloud on the basis of some variable. Word cloud on the basis of some variable. I am showing that Uttar Pradesh, the population the highest, followed by Bihar, Maharashtra, Rajasthan, like this. Then Shanky charts. So you may have created these Shanky charts, infographics. So different infographics we can also create it like this. And play axis. So you can see that the chart is playing automatically. So we can create it the play axis charts. Scrollers. You have seen all these charts in different places. So now the question is that how to create these scrollers in your data set, in your presentation. So how to create this? Then we are having a sunburst chart. So if you click on any part, the value will come. Okay. So why I am showing you, because actually I am offering a workshop on this from 3 January to 7th January, and the fees is only 799. So मैंने सोचा कि थोड़ा सा टाइम है तो थोड़ा सा अपने बारे में भी बता दूं. So sorry for including my personal workshop in here. So basically, my passion is to do research. My passion is to learn and provide training to the others. So this year I have 3 A category publication, 2 B category publication, and some other Scopus publications. So, and my 5 or 6 publications are also in pipeline. And this is my passion to do research and train others. So thank you very much.
Sir, I have one more question, if you
Yeah,
allow
please,
me.
please.
Sir, in this entire 4 days workshop, like we have learned a lot of softwares which are used for structural equation modeling, right?
Yeah.
Earlier, I had used only a MOS. So, just can you please give me a review of all the softwares and the latest techniques that we use for current research now? Just a summary in 5 minutes.
Basically, nowadays, the meaning of research is already changed because the research which we learned 10 years back is not now no more. So, structural equation modeling, I start teaching in 2000 from 2008. I'm telling you, and actually, I believe that in India I started the providing training in MOS. But now I know that there are five softwares which you can use for structural equation modeling. And if I put a hierarchy, then MOS is number one, the PLS is number two, Adanco is number three. Then you can go for Stata and R. But I believe that if you even don't study Adanco or R or Smart or the Stata, Smart PLS and MOS, along with the process, you can develop 99% of the models in only these softwares. No need to go to any other software. So if you have command in MOS, PLS and process, I think you can write a good papers. Now, the second question you are asked that how which research topics? So I'm telling you, in India, I found that the most of the scholars. So let me give one example. So last month, one scholar came to me and told me, sir, please suggest me some topic for a synopsis, PhD synopsis. Okay, then I gave her a very interesting topic, the application of artificial intelligence in financial domain. So I gave the topic to her and helped her in making the synopsis. Now, when she presented the synopsis to the panel members say that this is very advanced topic and you are not able to do the advanced topic. So take some old topic. Though this topic you should not take. So the problem is India is that if you want to do good work, nobody will support you. This is the problem, right? So and one topic which where I am also interested in doing research, that is called neuromarketing. Because as a marketing people, we are doing a lot of neuromarketing strategies to influence others, right? But when I started doing literature review on neuromarketing, you may not believe, I do not found more than 30 research papers on this topic. But so it is a very good topic. Similarly, in 2017, when I started research on blockchain, I have not found any paper on in at that time. So I started doing research in 2017. Paper we submitted in 2019, and finally it published in 2021 in A category journal. So you can understand that how much patience and hard work is required for writing a good research paper. But I'm telling you, this year itself, in 6 months, my citation, I got 35 citation from that paper. So if you do some good research, people will cite you. People will, and this paper is the top 50 paper in that category. So the question is that if you want to write a good paper, your topic should be good. Your research problem should be innovative. And then your contribution should be significant. I hope you got your answer.
Yes, sir. Yes, sir. Thanks a lot.
Sir, may I ask a question?
Yeah, please.
Sir, as you told that in Likert scale, the problem of biasness by the respondents, that if we use 5-point Likert scale, there may be problem. So, sir, I wanted to ask, I am studying the behavior of rural consumers. So, sir, if we tell them, for example, in 5-point scale, agree or strongly agree or undecided disagree or strongly disagree. So, in agree and strongly disagree, they are little bit confused. So what they are little bit confused. Their answer is that if I am agree, then I am agree. So they are not aware of the, yeah, yeah, or we can say that they are much confused. So sir, to reduce response bias, if we go to 7 point liquid scale, what would you suggest in rural context? Should I proceed with
Okay,
5
actually,
point?
I'm giving you a very simple answer of this.
Yes, yes, sir.
Actually, human nature. If you ask anybody that how much number you want to give to this movie out of 10-point scale, human mind is very quick in answering that. But if you make it complicated, that one means this, two means this, three means this, so that is a very complicated thing, right? The easiest scale, I believe, is that 1 to 10 scale. If you ask somebody that you have seen this movie or you eat the food in this restaurant, now how much marks you want to give to the food out of 10? You will get accurate answer, best answer, I'm telling you. But the problem is that in 5 point scale, the problem of is of normality. The problem is of the the biasness. The problem is of discriminant validity. So as a statistician, I know that the 5 point scale is having a lot of problem. But for from respondent side of view, respondent point of view, respondents are more consistent with this scale. This is true because giving response is easy. But I'm telling you, if your respondent is educated, even 7 point scale is much better. There is no difference between responding in the 5 point scale, in the 7 point scale. I don't think any difference. So if you can get responses in 7 point scale, why not you are using that? So once at a time, I asked the Dr. Pasuraman, who developed the service quality scale, and he told me that I developed the scale of service quality in 9 point scale. So the original questionnaire was developed in 9 point, but the problem is that when that same questionnaire come to India, it converted into 5 point. So then that is the problem.
Because sir, when I went to the field, that I faced the problem. So I was maybe I was unable to convince them that this means this, or maybe some they are rightly they are straightforward in their answers. And if I agree with that, then I agree with that.
Yeah, but actually, I'm telling you, we are very far behind in terms of research. India is very far behind. And because once, 2 years back, I did a survey. I collected the 100 research papers of A star and A category and start counting the how many of them are using 5 point scale and how many of them use 7 point scale. I found that more than 70% of the researchers, they used 7 point scale. Very few used 5 point scale. But in India, if you find out Indian paper, if you do a survey on the Indian papers, I'm telling you 99% people use 5 point scale. Nobody want to use 7 point scale.
Okay. Thank you so
So
much,
these
sir.
are some of the problems that we statisticians are facing.
Thank you so much, sir.
Any participant want to ask anything? It's a very golden opportunity that sir has some time to discuss the thing, because we planned the session accordingly, so we can discuss most of the things with the sir, because the topic, if we will give to him, then it's a piece of cake for him to cover any topic in a moment of time. So that's why we planned that most of the time we will do with the question and session, because you might be stuck with your own research paper or sometime research proposals or something like that. So any sort of experience you want to share, or you want to take your suggestion, this is a very golden opportunity. You may not get that type of platform. So I'm requesting to you, if you have something in mind, you please come out. That would be the learning curve for every one of us. think there is some question in the chat box.
Is there any specific rule to split the size to 50% EFA and CFA? Actually, why I'm telling you that whenever you send a paper for publication, most of the reviewers suggest you to apply EFA and CFA in different data set. So that's why from this review comments, I came to know that EFA and CFA should not be applied on the same data set. It should be applied on the different data set. So whatever I am telling you is this is the reviewer's point of view about EFA and CFA. Yeah, Orange software is a machine learning software, and it is very excellent software, latest development. So I will conduct a workshop on Orange also very soon.
Let me tell you all of you that sir has a very wide range of research methodology workshop with a very minimal cost. In our group also, I will definitely share the workshop which he will conduct. Actually, if we can spread it with our networks, then obviously we will find a very good environment, research environment. Actually, the environment will make us, a better researcher. It's not alone we can do miracle, but we need the team, we need the people, we need the beautiful environment. So that is possible only when we encourage. So we will share the things which whatever whenever I have requested sir also. So whenever he is conducting something and his research workshop or the thing he conducted, the beauty of this is that will not hamper our uh, uh, day schedule, because it normally, yeah, they have qualitative, quantitative, a lot of things. I will discuss with the sir, and we will make a very good structure of that, because sir has a limited sir is very hesitating to share those things with the audience, because sir is a very different type of person. But we will market it for the sir, and I'm requesting all of you that whenever we will do that, we please spread it across so that the things would be give a better result. And I'm telling to you that if any participant, because of your effort, if they will learn certain things, your citation will improve. Definitely, I'm saying, if you will support someone to get a good knowledge in the research, academia research, then that person will definitely recall your research papers also. So that's the beauty of this this profession. So thanks sir for giving a precious time to us, and we will inshallah meet you again. And I'm telling to you, what whenever he will do the workshop, that will not hamper our day schedule. That is very separately designed, and it is designed because of our work schedule. So qualitative, and there are many. I will share one by one whenever he will do that. So sir, I told you that we will make the things bigger, sir, inshallah. And sir resides in Mumbai, and we are from northern part. Most of us are from northern part, and some of us are from the southern part and eastern part as well. So we will create a bigger platform. So thanks a lot, sir, for giving your precious time to us, and whatever you have given to us, we will try to make it in our practice, because practice matters a lot. Maybe this time, that moment of time, we was engaged somewhere, we was not that much involved, we don't have that much questions. But after some time, whenever we will schedule our timetable and something like that, we will definitely come across the problem, and we'll again come with you, come with this problems. We'll mail our problems, and inshallah we will get a very good reply on that problem. So thanking all of you for participating. I need two volunteers for tomorrow's session. That was the last session. And the first session is with Priya ma'am, sir, as you told us, for ANN, and she's a perfect. She's from JNU. And the second session is from the industry for on he's a chartered accountant. He's running some company for training the human minds and our food habit, and something more interesting which we are normally daily on a routine wise we are encountering with our
Sir,
Okay, sir. Thank you very much.
Thank you, sir. Thanks a lot.
Thank you so much, sir.
Thanks.
Thanks a lot, sir. And Ajay sir, I'll be reaching out to you for that neuromarketing thing, because for the last 2 years, I'm trying to work on that area. So I'll surely reach out to you, sir.
Thank you, sir. Definitely.
Asad sir, I would like
Yes,
to
yes.
volunteer for tomorrow, sir. Introduction. Prajakta here, sir.
Okay. First session, Praja.
one more person is needed.
Thank you, sir.
Thank you, Projekta. The second person would be. Sorry, I was disconnected. Okay, you can reach out to me. Okay, whomsoever is ready, you can reach out to me. Sir, so can we end the session for the day?
Yes, sir. Thank you. Thank you so much.
Thank you, sir. Thanks a lot.